Okay, last time we were using the sort command, and we were trying to sort the content of this file, tstra.txt. We see its content again. It has a list of Linux distributions like SUSE, Fedora, Ubuntu, etc., and release number or version number and release date. And we tried to sort it first by the name of the distribution, which is in the first column, sort with key 1,1, just using the first column as the first sorting key. If we miss this comma 1, then it will take from the first column to the end of the line, which is not what we want. That's why we write key from 1 to 1. And then the second sorting key was the second column, and this n is numeric. So it is going to sort in numerical order, not in alphabetical order, which it does by default, and the name of the file. And so we see that F comes before S, so Fedora comes before SUSE, and so on. And then we have 5, 6, 7, 8, 9, 10, and so on. Now suppose that we want to sort according to the date in reverse order. So we want to sort by the release date. Then we can do sort tstra.txt, and then the first sorting key is 3.7 NBR. The second key, I will explain what this means. It's 3.1 NBR, and then the third sorting key, or the key that will be used for sorting, is 3.4 NBR. Now, this 3 means the third column, so it will start sorting from the third column. But this 0.7 means it will start from the 7th character. It will start sorting from the 7th character of the third column. So third column, 7th character. So third column is this one, and the 7th character is here. So it is going to sort from here up to the end. This is the first sorting key. So it will first sort by year, by the number of the year. And then this N is numerical sorting. This R is reverse sorting. So from the largest to the smallest, not from the smallest to the largest. And this B here is to ignore any white space or empty space or blanks. B is for blanks, to ignore blanks in front of the third column. And again, the third sorting key will sort by the third column, starting from the first character. So it is going to start sorting from here. So this is the month, because these are in American format, in which is month, date, and then year. So this is the month November, for example, and then this is the date. So the first sorting key is by the year, and then the second sorting key is sorting by the month, and then the third sorting key is third column, starting from the fourth character. The fourth character is here, so it will sort by the date. So first sort by the year in reverse order. So do me 2008, 2007, 2006. It comes from the biggest to the smallest. This is a reverse sorting order. And then 11 comes before 10. It is reverse sorting order, comes before 06. So it is sorting by the month. And then the last sorting key is by the year. For example, here we have the same year and the same month with this one. But this comes first because the date is 18, which is larger than 004. Now, when we say third column, use the third column as the key. It separates the columns by a tab or by empty spaces. So this is the first column because here we have a space, and this separates the first column from the second column. Actually, we have a tab. It is a tab here. And then here we have another tab which separates the second column from the third column. So by default, the columns are separated from a tab or from a space. But in some cases, in some files, columns may be separated by another character, for example, by a semicolon. This is the case, for example, with the file etc password. etc password. So in this case, the first column from the second column is separated by the first field from the second field is separated by a semicolon, and so on. So the fields are separated from each other with a semicolon. In order to use as a separator to tell which character to use as a separator, we can use the option -t. For example, sort t. Use this one as a separator between different fields, and then I'm going to sort this file. It is the password. And then I want to use a sorting key. The seventh column. The seventh column is this is the first one. This is the second, the third, the fourth, fifth, sixth. 1, 2, 3, 4, 5, 6, 7. The last one is 7. So it is sorting by the shell of the user. Let's see what it does. So all those that have bin bash as a shell are on the top. And then comes this bin false. Let's actually do it with less. And then bin false, and then bin sh, and so on. So it is sorting in this case by the seventh column, which is the shell of each account or of each user. Now we will see another tool for text processing, which is called cut. It is used to cut one column or to extract one or more columns from the input. For example, if I say cut F3 distros.txt, then it is extracting only the third column or the third field. We can say that this is a field. So cut field number 3 or the third field. So it is extracting only the first field from or the third column from this file. Or we can say, for example, cut 1,3. 1,3 means extract the first column and the third column. or if we say 1 minus 2 comma 3, then this is like a range. So it will extract from the first to the second, and then it will extract also the third column. Or we could say also, for example, 1 minus 3, it will extract all three of them, or 2. So if a file has many columns, for example, and we say from 3 to 5, or from 3 to 6, then it will extract 3, 4, 5, and 6, these columns. It is like a range. If we say 3, 6, only the third and the sixth column. Let's say that we want to extract the year from this file, these distros. So we want to extract only the year. How can we do it? There are a couple of ways that we can do it. First way is that we can first extract the third column. And then from the third column, we can use a separator, this slash, and then extract again the third column. So this command will give me this result. But now I can pipe the output of this command to another cut command, and I will use this delimiter. In the case of cut, I will use this slash as a delimiter to separate columns from each other, and then I will extract the third column again. So by default, the command cut uses the tab as a delimiter, same as the command sort. But we can change the delimiter with the option -d. In the command sort, it was -t. With the command cut, it is -d. So I'm changing the delimiter that separates one column from each other to slash, and then I'm saying extract the third column, or the third field. And so I'm extracting all the years. Another option for extracting the year is this. First of all, we extract again the third column, and now we use the command cut with the option -c. And when we use it with the option -c, then each character is considered as a field or as a column. And then I'm saying 7 minus 10. And it will extract from the 7th character up to the 10th character. So the 7th character is this one, and up to the 10th character is this one. So with the command, with the option -c, every character is considered as a field. And then we count fields from 7th to the 10th, and then we extract only this one. And if we want to extract, for example, the year, the month, and the date, then this command extracts the year. And now the month is the first and the second column. So I say from the first to the second, and the date is from the 4th to the 5th. But you'll see that although we say from the 7th to the 10th first, it is still in the order of the input. And again, the month is still the first, and the day is still the second. Yeah. So this does not change the order of the columns or the order of the input. It is outputting them in the same order. Now, another way to get the full year. So with this method, we cannot get the full year correctly. So let's try another one. And another one will be like this. For example, expand distros, cut, C, 7, 23. Or no, from 23 up to then. Now, what does this expand do? This expand converts tabs to spaces. So if we say cut A, we see that actually here we don't have spaces between the fields or between the columns. We have tabs, and tabs are Control I. Are denoted by Control I in this output. So this option shows the special character. So tab is a special character that is replaced in the screen by several spaces, but actually as a character it is different from a space. It is a, and when we do expand and then cut. Now, this expand actually is replacing the tabs with the corresponding characters, and now in the output we have only spaces, no tabs, and so this allows us to number the number of characters up to here. This is the 23rd character. And so we say extract from the 23rd up to the end. The 23rd is this one here. So we say extract the characters from the place 23 up to the end of the line. And again, with the command, we want to extract some fields from etc password. In this case, we have to use this semicolon as a separator. So we can say cut the delimiter. We can think of this option as delimiter. We can use this semicolon as a delimiter. And let's say that we want to extract the username field. It is the first field number 1, and the number of and the name of the file, of course. So we are extracting only the first field using this one semicolon as a delimiter, and the first field is the username of each account. So this much for the command cut. Now we'll see the command paste. The command paste, which actually does a kind of reverse operation with cut. So the cut separates one input file in several columns, or extracts columns from an input file, and paste joins two different files in a single file. So the columns from one file and the columns from another file are pasted in a single file. Let's see this with an example. First, let us sort distros by date. And we have seen this command sort. I'm searching upwards. Okay, this is the command that sorts the distros by date. And let's save the output of this command to the file named distros by date. Distros by date. So distros by date. They are sorted by date. And next, let's use the command cut to extract the first two fields from this file. Cut field 1 and 2, distros by date. The first two fields are the name of the distro and the release date. And let's store it into the file distros versions. So we have a column for the distros and one column for the versions. That's why we call it distros versions. Now let's use the command cut again to extract the release date. Cut. So this is the release date, or the third column of this file. And we store it again to the file distros dates.txt. So we have only the column of dates in this file. So now we have two files. Distros. We have two files. Distros dates and distros versions that have these columns. And now we can use the command paste to join these two files, the columns from these two files. Paste distros dates, distros versions, and let's save it to the file distros chronological. Now let's see what is in this file, distros chronological. So it is the first column, which is taken from distros dates, And then there are these two columns which are taken from the file distros versions. So the columns of this file are pasted with the columns of this file in another, and the output is saved in another file. So this is how the command paste works. It is in a way the reverse operation of the command cut. Another command that is used in text file processing is the command join. This is similar to the command paste, but with a small difference. Because when we join two files, they must have a common column. So there must be a column that is both in the first file and in the second file. And the command join is joining the lines from the first file with the lines from the second file, where the column that is used as key or as ID is the same. So it is making a kind of matching between the two files. So let's see with an example how it works. So actually, we have this command, this file distros dates. Do we have the file? But now let's extract the name from this file, distros by date. So we want to extract the first field, the name, and we extract it with cut F1. Distros by date, and we name it distros names. Now we use the command paste that we just saw before to merge these these two files, distros names and distros dates. So we will use the command paste to join them together. Paste distros dates, distros names, and then we will store it the file distros names. And distros names, and we are calling this column key, and these are the names. Why we are calling it key? Because we will use this column to join with the next file that we are going to create. So let's extract also the version numbers from distros by date. So let's extract also the version numbers of this column. cut field 2 distros by date distros versions dot text add distros versions. So we have only the version numbers in this file, and we have the dates in this file. We will use the command paste again to join this, to paste these two columns. Paste distros dates and distros versions. Distros add distros versions. So in this file, we have the column that we are going to use as a key and the column of versions. And in the other file, add distros names. We have this column that we are going to use as key and the column of the names. So these two files have a common column. So the column of date is the same or exists in both of them, in both of these two files. And finally, we can use the command join to see how we can join these two files. Join distros key names and distros key versions. Text. And let's see what we have here. So this is the common column that is in both of these two files. And then here is the column from the names, and next the column or the field from the versions. And it is joining the lines that have the same date. So if we have the same date in both lines, then they will be joined in a single line. So one line from this file and one line from this file, if they have the same date, then they will be joined in a single in the second line, because we are using the date field as a key. Now let's see how we can compare two text files. Let's create two example files first. Cut, and then save the output of cut to file one.txt. Then Control D. Control D means end of input. Cut file one. We have this content in file one. Now let's create a second test file. And then let's see. And then Control D, end of input. File2.txt. It is this file. Now let's use the command com to compare these two files. Com is a shortcut for compare. File 1 and file 2. Now it is outputting 3 columns. In the first column are the lines or the fields that are only on the first file. And in the second column, there are the fields that are only on the second file. And the third column are the fields that are both in the first and in the second file. And we can, if we give this option, for example, to command com 1, 2, then it is going to display only the third column, -1 and 2. It is not going to display the first and the second column, only the third one. The third one are the lines that are the same in both files. But this command com is very simple and not used really. There is another command which is much more powerful, which is called diff to find the difference between two different files. For example, diff file 1.txt and file 2.txt. It shows us that at the first line, this line with A is only on the first file, or on the file on the left, and this line E is only on the file on the right, on the second file, and the rest of the files are the same. We can use some options to make the output more easy to understand. For example, with the option -C, this option means context. So it is not just displaying the lines that are different in the first file and in the second file, but also some other lines around them. So this is what context means, the lines around them. So here we have file 1.txt denoted by these stars. This is the first file. And in this range of lines, from the line 1 to the 4th line, we have this line only on the first file. So if we want to change the file 1 in order to make it the same as file 2, then we have to remove this line from the file 1. And we have to remove this, to add this line to the file 1 in order to, and then file 1 will become file 2. So this is why it is denoted with minus, and here it is started with a plus. So if we remove this line from the first file and we add this line to the first file, then it will become the same as file 2. So it is showing the differences. And the option -u means unified. Unified, it is because here we have a range of lines from 1 to 4, and it is showing us what we need to remove from this range of files. And here we have almost the same range of lines from the first to the fourth one, and it is showing us what we need to add to this range. But here the removals and additions are unified in a single chunk. So here we have -a, and then at the end here these are the lines that are the same between both files, and then we have to add this line in order to make file 1 equal to file 2. And with the command diff, we can create a so-called patch file. A patch file means what changes we should apply to file 1 so that it becomes the same as file 2. How do we create a patch file? We just save the output of this command diff u to a file. It can be text, doesn't matter. But usually when we create a patch, we also add some other options like and this R is for recursive, I think, because it can compare also directories recursively, and also these two other options. And let's create the patch file and then see the content of the patch file. So here we have the first file denoted with minus and the second file denoted with plus. So we need to remove this line from the first file, and we need to add this line to the first file in order to make it equal to the second file. And we can actually apply a patch using the command patch. For example, this command patch apply to file 1, apply so patch file1.txt with these changes in this file, and then it says patching file1.txt. Let's see what we have on file1.txt. It is actually equal to file2.txt. So now it has become equal to file2.txt. Because this patch file contains the changes between file 1 and file 2. And if we apply these changes to file 1, then it will become equal, or it will become the same with file 2. Now we will see some other interesting and beautiful commands, which are about editing files on the fly, or editing files with commands from the command line. One way of editing the files is with an editor like Nano or Vim, but we can also edit them with commands. One program is tr, which means translate. And let's see an example with translate. And then we are piping this line to the command tr, and then tr is these options. So what is happening here is that here we have two lists of characters, 26 lowercase characters and 26 uppercase characters, because this is a range. And the command translate will replace the first character in the first set with the first character in the second set. And then b, lowercase b with uppercase b, lowercase c with uppercase c, and so on. So it will replace each character with the corresponding one in the second set. And usually the number of letters in both of these sets should be equal. But it doesn't have to be equal. For example, let's see this example. Translate lower and then A. So here again we have two lists of characters, or this is a character class. which contains all the lowercase letters. We have seen it before with regular expressions and with shell expansions. But now you see that the second set of characters contains only one character. So what is going to happen in this case? So every character actually is mapped to this one, because this is the only one. Let's say that we have A and B, for example. Some strange things are happening, because it seems like it does it almost randomly. So if this set is larger than the first set is larger than the second set, then the mapping is done kind of randomly. But it makes sense if there is only one, because all the characters in this set will be replaced with this character, and this makes sense. In this case, it is deterministic. It is not a random behavior. And with this command translate, we can also delete some characters if we use the option -d. For example, delete all the characters E. And we see that all the E characters are removed. This one, this one, this one are removed from the input. Or let's say delete E and T, for example. Then the T character is deleted as well. So delete all the characters in the given set. And we can use the command tr in another case as well, like this one. For example, suppose that we have some repeating characters. So some characters that are repeated. If we use the option -s, A and B, this -s means squeeze. Squeeze means that all the repeating A characters are replaced by only one A, and all repeating B characters are replaced only by one B. So this means squeeze. It removes repeated characters and replaces with them with only one character. And let's see a kind of solving a problem with using this command tr. For example, let's say that we want to encrypt a file or an input. And we can use the encryption scheme ROT13, rotation 13, which does this. Each character in the alphabet is replaced with the character that is 13 places away from this character. For example, if A is the first letter of the alphabet, then N is the 14th. So A is the place number 1. Is in the place number 1, and N is in the place number 14. Now we want to replace A with N, which is 13 places away, and then B with the next character that comes after N, and so on. And the Z character is the last letter of the alphabet, but it will go from the beginning. The counting will start from the beginning and will go up to the M. character. So Z will be replaced by an M, and we can do it like this. The command tr for translate, and then we want to replace from A to Z. We want to replace it with N to Z and A to M. So here there are 26 letters in this class from A to Z, 26 letters of the alphabet. And here there are 13 letters from N to Z, because N is in the middle of the alphabet and Z is the last one. And 13 other letters here from A to M. In total, there are 26 letters. So N will be replaced by N, Z will be replaced by M, and all the letters in between. But we also want to do this for uppercase letters as well. So we can add this list of characters here and also here, from N to Z and from A to M. And so now this text becomes this one, kind of encryption. It is a simple encryption, but and now if we want to decrypt this message or this text, we can apply the same replacement, and then we will get the original message. We will get the original message. Why? Because suppose that we have the character A in the original message. After we encrypt it, it will become the 14th character, which is N. And then after we apply this translation again, it will move again 13 places and it will become A again. And the same with each character. So after applying this translation 2 times, then we get the original message, which is this one. Now, another very useful program, which is used especially in scripts, is the program SED. SED means Streamline Editor. So it is an editor, but it can be used on the command line. It gets an input, modifies it, and then sends the modified output to the screen. And let's see some simple examples with SED. For example, the input is this one. And then we pipe it to the command SED. And then we use this command. So this S means substitute. So it is a SED command, which means substitute. And here we have, no, so there is something wrong here, from. So this means substitute. So it will search for this word, and if it finds it, it will substitute it with this word. Actually, this is a regular expression. It can be any regular expression here, and it will match the regular expression, and it will substitute the matched part of the text with this one. And actually, we can write this command like this. and it will still work. So this character is called the delimiter, which delimits the command from the matching part and from the replacement part. And the first character after the command S is automatically recognized as the delimiter. So we use it again here to denote the end of the pattern, the matching pattern, and to denote the end of the replacement pattern. Because sometimes it may not be convenient to use this slash, so we are able to use some other character as the delimiter, any other character. And the command substitute can also take in front of it an address or a number line. For example, if I say 1 and that doesn't matter, there can be a space or not, it says applies this command only to the first line. And the first line, this is the first line, so it is applied, and we get the replaced text. But suppose that I say apply this command to the second line. Now the input is not modified, it is the same, because this replacement is meant to be applied only to the second line, but there is no second line here, so it does not touch the first line. Let's try this example with the file distros that we saw before. One, 5 p, and then distros.txt. Now, what this is doing, it is printing the lines from the range of lines from the first to the fifth. Usually, the command sed will output all the lines of the input, but with the option -n, we are telling it not to output the normal lines. And here we are telling it that for the range from 1 to 5th, the command P is print. Print means output this line. So it is outputting just the first 5 lines of this file. And let's say that we replace this range of lines with this pattern. Now it will match all the lines to this pattern, and if the line matches, if it finds a match, then it will print this line. So now we are printing all the lines that contain SUSE in them. And if we add this exclamation point or exclamation mark, then it will print all the lines that do not contain SUSE. So it reverses, or we can actually it can be written like this. So it will match all the lines that do not contain SUSE. So without exclamation, it will match all the lines that contain SUSE, and all of them will be printed. But with an exclamation mark, it will match all the lines that do not contain SUSE, and all of them will be printed by the command P. So there are some more examples with the command sed, but let's continue with them on the next lesson, which is on Friday.